Okay, so today we have Dr. Michael Schuckers, who's going to speak to us about skater evaluation in hockey using regression adjusted plus-minus. Dr. Schuckers is the Charles A. Dana Professor of Statistics at St. Lawrence University in New York in the United States. He obtained a master's at the University of Michigan and a PhD in statistics from the Iowa State University. His research interests center on biometrics and fingerprint recognition specifically, and sports analytics. He has founded a company which I believe is called Empirical Sports or Statistical Sports Consulting. Michael, please correct me if I'm wrong. He is also associate editor of the Journal of Quantitative Analysis in Sports since 2011, and he's a co-organizer of the Ottawa Hockey Analytics Conference. And today his topic centers around regression adjusted plus-minus, which is a statistical method that is often used to evaluate individual players in team sports. So this framework has been primarily used in basketball and hockey, but recent applications extend to soccer and football. So in this talk, he will introduce the basics of regression adjusted plus-minus and discuss one implementation of it for skater evaluation in hockey. Results from the NHL season from the 2017-18 and 2018-19 seasons will be discussed. So with that, if there's no questions or comments, I will turn it over to Dr. Schuckers. If you could just please, I'll stop sharing my screen and have you share yours, and I'm going to put it on speaker view here for everyone.
So I guess I'll start. Can you see that?
I can, yep.
Excellent. Well, Dave and everybody, thank you for that introduction and welcome. It's an honor to speak to you. As Dave mentioned, I've been out to Vancouver a couple of times. I even participated on a PhD committee of one of Tim's students. And one of my college roommates actually is a professor at UBC, so it's always nice to get out to Vancouver when I can. Just a little bit about where I'm coming to you from. This is a map. You probably are familiar with some of it. The Ottawa and Montreal part there, just across the border in northern New York there. Canton is a town of about 10,000 people on the edge of the Adirondack Mountains are down here. St. Lawrence University, where I teach, is a small school of about 2,400. So despite the fact that we've got a university in our name, we're closer to a small US college. We have maybe 15 or 20 graduate students a year at an education program. So primarily undergraduate education. But our proximity to Canada allows us to do a lot of things. And for me, I grew up in Pennsylvania, not too far away on the grand scale of things, but grew up playing football and a little bit of baseball. When I took the job up in northern New York, suddenly I'm in this little tiny town, but there are 6 hockey rinks within 20 minutes of my house. And so as my kids grew and started playing hockey, became more and more interested in doing and working on hockey, and very good friends with a lot of the hockey coaches at St. Lawrence. Despite our being a small school, St. Lawrence plays at the highest level of hockey in the US at the college and university level. So we are in a league with Harvard and Yale, and we regularly play Wisconsin and Michigan. Despite them being much larger schools, we play at that high level. So that's a little bit of background on me, where I'm coming from. As Dave mentioned, going to talk today a little bit about a regression adjusted plus-minus. And really the goal of this methodology is to try and isolate the impact of individual players in a team sport, right? And so often used, but you can think of, right, how do I take and try to piece out or pull out the impact of an individual player in hockey, in soccer? Tim's done some work in pickleball, so I'd throw a pickleball example in there. right? And as I understand Tim's work, there are doubles in pickleball, so you're trying to pull out an individual. But another sport where there's been some recent applications is volleyball, right? Whether that's beach volleyball where you're 2-on-2 or more traditional sort of 6-on-6 volleyball. And so, with all of these sports, we have a lot going on, and how much an individual player impacts any of those outcomes is very difficult because, I often like to say that hockey is a 40-dimensional problem, and 12 of those dimensions are the players, and then you have other dimensions going on like time and game scenario and score and those sorts of things. And so, we're really trying to sort of piece and isolate that. So yeah, that seems like an easy thing, no big deal. We're just going to try and pull out those impacts of individual players. So then the goal here is to build a statistical model, and we're going to take observational data. So from a statistical perspective, we think of observational data versus sort of design data collection, and a lot of the correlational issues that go along with observational data. And we're going to try to isolate the impact of individual players. So the big idea here for regression adjusted plus-minus is we're going to have a fairly large data set. We're going to take a regression model approach. We're going to have a parameter or two, can possibly even do more for each player. We've got to think about appropriate observational units. What does that look like? Dealing with additional covariates and factors that we want to have in that model. We've got to think about what is a useful response for that, and then think about sort of the actual methods that we're going to use for estimation once we've got that model in place. So those are sort of the big pieces that I'm going to sort of walk through as part of this. But going back, to a Canadian audience, I probably don't have to say too much about this, but it's worth saying, right? So starting with plus-minus in hockey, and plus-minus has been used in other sports, but primarily comes out of hockey. So, when good things happen, when a player is on the ice, they get a plus. That's a goal. We're going to potentially extend that beyond, when bad things happen on the ice, they get a minus, right? And so the idea is to say, okay, we have that information, right? But we also know that, if you're out there playing against, right, Crosby or McDavid, right, you're potentially going to get a lot of minuses, and that may not necessarily reflect how good or bad you are, right? So much depends upon other teammates and on opponents. And for example, I just pulled up some Canucks, right, plus minus from this past year, and Troy Stecher, I think is the pronunciation there. Sorry, I'm not as up on my Canucks as I am on, say, the Senators. Was a plus 10, and Bo Horvat was a minus 15 there. And so I'm not so sure that that's maybe the best indicator of the quality of those individuals. So we'll take a look and see if we can isolate some factors. So here is sort of the regression model. So digging into a little bit of the math. So we're going to have some response Y, and in a statistical sense, we're going to have an intercept. Again, our subscript I here is going to respond to an event, and we'll talk about what events we might choose, what events might be available to us at this time. If there's time at the end, we can start thinking about maybe what's going to be available to us in a couple of years, fingers crossed, in terms of tracking data. But for now, we're just going to label that an event. And what we're going to create is we're going to create a parameter here for each player. So I'm going to have then just this standard sort of linear regression. So I've got an additive model here, right? Each of my beta coefficients is going to represent a player, and sort of the average effect of that player on our response. In the formulation I'm going to start with, that intercept beta naught or beta 0 is going to be a home ice effect. And the X of ij's are going to be indicators that are going to tell us who is on the court or more generally on the ice for a particular event. And just to lay it out here in terms of this single parameter per player, then that sort of value X is going to be an indicator of whether the player is on the ice or not. And we're going to say it's negative if they are on the ice for the away team and positive if they're on the ice for the home team. And we're going to say it's a 0 if they're not involved. And so what happens just roughly back here, right? If I've got those X's, right, being 0, then what happens is the effect of all those players who are not on the ice is taken out of the event, and I'm going to get a sum of events that are positive for the players on the home team, negative for players on the away team. Okay. Then this is sort of what statisticians would call the design matrix, and this is sort of the big view of what becomes the part of that when we sort of aggregate all of those X values together. We're going to start with a column of 1s, indicating we always have some home ice effect. Actually, not always the case, right? If NHL's recently played some games in Stockholm and other games in Europe, and so you may not actually have some home ice. If we look at what's about to start in a week, right, with the qualifying round and the playoffs at the NHL, you may not actually have a home ice effect there. So then we would have a series of 1s for the home team. We'd have a series of -1s. For now, I'm just putting in 5 skaters. We can put goalies in there or not, but for now, we're just going to worry about even strength 5-on-5, 5 for each side, so 5 for the home, 5 for the away, and then the rest of that row is going to be 0s. And so the first 2 rows that I've illustrated here, right, I've got 2 events back to back, right, where I've got these players for the home team and these players for the away team. And again, we end up with something like about 1,000 players here. So we end up with about 1,000 columns in this design matrix, right? And then, of course, those rows are going to be, as we aggregate, we get more and more events from more and more games, or even we get different players on the ice from the same game, right? These 5 players may have, right, their shift ends, they go off, but maybe the away team players are still on, and maybe that same 5 come back on later, and then a different lineup goes out on the ice for the opponent. So we end up with a fairly large matrix. We're going to create a matrix, 1 column for each player. By doing 1 column per player, we end up with an effect that really is a 2-way effect. And so I mentioned that we can have 2, we'll go through and break it down, but you can break this out into looking at offensive effect and defensive effect. And then you end up with an even fuller matrix with 2 parameters for each player. So there's the matrix view, right? If we add the offense and defense formulation, then what we had before was just a single value. I've now added some superscripts for offense and defense. Our indicators, our X's previously were -1s, 0s, or 1s. Those now become just simply 0s or 1s. I've left it here as on the court, but generally on the ice here. Our home ice effect, that changes up from being simply a column of 1s to now an indication of whether the home team was doing the event or not. Until we get, again, a bit more complicated. So in the first case, we had, right, for a full NHL season, we get about 1,000 players. If we do sort of a 2-way representation, if we do an offensive and defensive representation, now we've got 2,000 columns there. And so this is the more complicated version. Again, this is the sort of design matrix fully laid out there for an offensive and defensive ratings for each player. So that is just looking at sort of how we're trying to isolate impact of individual players by knowing who is on the ice for a particular event.
Michael,
the same true.
Michael, sorry, can I just interrupt you quickly there? How do you decide on like what players involved in the offense or defense? Is that through spatial data, or just through their play-by-play, or by position?
Yep. So it is by the play-by-play. So one of the elements of sort of doing offensive and defensive ratings generally are events that are happening in hockey in a particular zone. If you had something in basketball, right, you could look at which end of the court things are happening on. Does that help?
Yeah, that's great. Thank you.
Yep. So each row, right? So we've talked about the structure. We haven't talked about what each row represents. I'm going to leave this broadly defined as an event. In hockey, it can be a shift where you have the same 12 players, assuming, again, 5-on-5, even strength on the ice. In basketball, the same, right? You have a period of time where you have no substitutions in basketball. So basically defined as when the same players are playing against each other. We can also sort of break those time periods, so there's shifts up. In the sort of example application I'm going to show you, I will go through and we'll have each event be an event that is recorded by the NHL in their play-by-play. Okay, here is that play-by-play, and to your question, Dave, this is where all of this information currently comes from, at least in the public sphere. There are some third-party folks who do additional data. So here we have a game that seems to have gone well for the Canucks back in March. And the first event, so we've got some starting events here. First event is a face-off. Vancouver wins in the neutral zone. Pajot and Sutter were involved. And we know the players who are on the ice. And by their numbers, we can identify them and we can have an idea of who is there. In the actual play-by-play, you can get a fuller description of the players, but what appears in the HTML is just their numbers and their positions. So you can have a face-off, a shot. If we are doing shifts as our events, then our first event would be just these first two rows. Because when we get down to this row here with a missed shot, right, Vancouver has made a line change, all right? And then you get down, we have a miss, the puck is frozen, and then both Vancouver and the Islanders make a change there. So we would have two events here and two events here, assuming we are going by NHL play-by-play. If we were using a shift, then we would have one event for these first two, what are listed as 5 and 6, and then 7 and 8. So that's sort of what becomes the rows of our matrix. Just back a little bit now that we've got that defined. So back to our mathematical model here, right? And mostly I just want to say here that really what we're doing with this regression is the impact of player J on this outcome. I haven't really talked yet about outcome. That's certainly to come. But now basically we have, when we get those estimated coefficients, they're going to be the average impact of player J on that response, trying to control for all the other players that were involved. So now we come to discussion about the response. So this outcome variable Y, it's been the left-hand side of our regression. And our good old plus-minus, right, that really was just goals. And we might give a +1 and a -1 when goals occur. The YI in general is going to be the value given to a particular event. And there's some ways that folks have traditionally define this. So I've stolen this table from a nice paper which does a little bit of a summary of regression adjusted plus minuses, and it looks at basketball, ice hockey, soccer, and volleyball. Just a bit about the characteristics of those. You're probably aware of these already. I'll just take the goals per segment. So in basketball, there's plenty of goal scoring, right? Plenty of points scored. And so you've got high goals per segment. Ice hockey, soccer, that's low. Volleyball, depending upon your segment, that would be medium. What that does is that tends to leave us with very little in ice hockey in terms of values that we could take for that response. And as a consequence, we moved away from using goals to say the probability that a goal is scored. So if we're using shots as our events, or we're using shifts as our events, we might aggregate what is the probability that a goal would have happened given those events, and do some averaging to do that. So just give you that sort of table as a little bit of background. The common responses, and this tends to be in basketball, is via points or change in points. Expected points or change in expected points happens more in hockey and soccer, again, because of the low scoring nature there. There's been some recent work looking at changes in win probability. That's pretty new and not as common. Though I did happen to notice that there was a rugby change in win probability talk in the previous series, and I'll have to go back and have to watch that seminar to find out what's going on there. So primarily in hockey, since that's going to be our focus, looking at expected points or the change in expected points, and certainly in the soccer literature, that's known as XG or expected goals. So now we have sort of the right-hand side and left-hand side. We want to estimate each of our coefficients, or the vector of coefficients there. So I'm going to just lay out here sort of ridge regression, one of the more common methods that are used. The algebraic formation is there. The lambda I will point out here is a shrinkage factor in the statistical literature. There's a couple of goals for that. One is to improve out of sample performance. The other is to deal with multicollinearity, sometimes known as the problem of the sedines in hockey, because the sedines appeared on the ice so much together, it was difficult to be able to isolate the impact of either one of them. And so when you have players that play a lot together, then your traditional sort of ordinary least squares does not do great in terms of how it handles that and how it estimates then your beta coefficients. And so using ridge regression helps to stabilize some of that. I've listed some other methods that have been used in the literature. Elastic nets are pretty uncommon, but Bayesian methods, lasso, really all trying to get at out of sample, but also out of sample performance, but also multicollinearity. So that gets us there. So maybe Dave, that's a good place to stop and take a couple of questions if there are any, because then I'm going to go in and talk about specific example and specific choices we made for our RAPM for hockey.
Perfect. Okay, thanks, Michael. Yeah, if there's any questions, please just directly ask or unmute yourself. I'll give about 30 seconds here. We don't have anything in the chat form. I think that's been really clear explanation thus far, so appreciate that a lot, Dr. Schuckers.
Hey, Michael, this is Tom Logan at SFU. I'm just wondering if you've mentioned a lot of linear regression methods. Is it at all common for any particularly non-linear methods to be used?
I would say it is very uncommon for that. Now, you know, that said, I guess it would depend. There certainly have been some logistic regressions used, and whether you think of that as sort of non-linear, I would tend to say that I think really additivity is maybe not necessarily the best assumption for some of these things in team sports, but it's a first order approximation and historically what we've done. There have been a couple of attempts to do things and look at some interactions, but for the most part, it really has just been a fairly straight linear regression.
Yeah, it's also the thing that's going to give you the clearest picture of the effects for each parameter rather than something that's a lot muddier.
Yeah.
Good, thank you.
Yep.
Okay, Dr. Tim Swartz has a question. Tim, do you want to go ahead?
Yeah. I was just wondering if your response yi is 0.8 minus 0.7, that's the same as a response yi that's 0.2 minus 0.1, but those are quite different types of games. One's wide open and the other one's quite tight. Does that come into play?
It's a great question. So you're thinking about using some sort of a difference in expected goals or expected points there. Yeah, I mean, I think traditionally in the models, nobody's looked at sort of the variability or sort of the sum of what you're getting when you take that difference. But for sure, it would be something that would be interesting to look at. Yeah, but I'm not aware of anybody who's actually used that information.
Great, thanks. Nathan Sandholz has a question.
Yeah, I haven't read as many examples of using expected goals or expected points, but so that's using model output as the response in the RAPM. Is that what you do when you're using expected points or expected goals or whatever it is?
Yeah, so in that case, I think what you're using is sort of an averaged value for a particular shot or a particular event. So in the example that I'm going to go through, right, we take all shots that were slap shots from a particular location and we sort of average the percentage of those that are goals to give us our expected points there.
Okay.
Does that make sense?
Yeah, I think so. But so presumably there's uncertainty about even that response itself, right?
Yes.
Is that uncertainty in the YIs? Does that filter through into the coefficient estimates of the RAPM?
Not directly, right? So we're, I guess it must in some way. If we are assuming that same slap shot, right, maybe from the blue line, right, that's maybe different if Chara is taking it than if Troy Stetcher's taking it, right? And at least in using the average value, we're not giving credit necessarily for whether it goes in. We're just saying this is an event and it's typical value.
Right.
Some of that in hockey is because we know that hockey, there's a lot of inherent variability in those sorts of events. Some of it also is just, I think, we don't have enough good data to really well model those sorts of things and say the impact of shooters.
Cool, thank you.
Yep.
Great, thanks everyone. Okay, let's move on with the presentation.
Sure. So I'm going to talk about a paper that we wrote, an implementation of this from 2013. So we called it the Thor, or the Total Hockey Ratings. and go through this. So our response in that case was that we took a particular event and we used events in the NHL play-by-play sense. So the probability of an event, whether that's a shot or whether that's a takeaway, a face-off win, probability that the home team scores within 20 seconds, minus the probability that the away team scores in 20 seconds. So our response there, again, positive if good things are happening for the home team, negative if good things are happening for the away team on that event. And then those line up nicely with our coefficients and our X values. We used a ridge regression for the stat folks. We tried to choose our lambda based upon getting the highest year-to-year correlation in terms of player values and our estimates in our betas. We did a two-way player value. In part, we were using all of the events, so things like hits and takeaways, and so wanted to view each event as having both offensive and defensive components, so we combined those. As I mentioned, events in the NHL play-by-play, hits and shots. We put in some additional covariates. We know in hockey that if your shift starts in the defensive zone, you're going to have less good outcomes on that shift. We also know that should be a score effect, that should be a difference of more than one goal. We also know that the score effect becomes very different and team behavior becomes different in the third period as the clock is winding down. Bunch of work is out there on differences in rink effects. Around 2013, that was true. That seems to have dissipated a good bit, and we left goalies in the model. So this is just even strength 5-on-5. You could certainly have a larger model if you wanted to include power play and penalty kills. So roughly here, some values for that response. Just pick out a couple here. So shots, right? The likelihood of a shot in the NHL is about 10% at even strength. And so backhands have a higher probability of that. Primarily, that's because you're only taking a backhand shot from in close. The NHL does takeaways and giveaways. We turn those into turnovers. And so a turnover for the home team led to a goal about 4% or a little under 4% of the time in the next 20 seconds. Face-off, small value, a little over 1 in 100. Hits by the home team, neutral ice, actually have a small negative value. And a hit by the team in their defensive zone, an even larger negative value. Again, the thought is that you're only hitting when you don't have the puck, and therefore that's probably not good for you and for your team. So I'm going to show you some results from that. I took the last 2 complete years. It's about 560,000 events, so 560,000 rows, about 1,500 players. I'm going to show you the number of times or the number of players, number of plays that a particular player was involved. And we're going to assume that 6 goals gets you an additional win. So you take the player's coefficient, sort of their average effect on a play, their number of plays, which should give you something like the number of goals added. Divide by 6, because there's some literature out there that says 6 goals in the NHL gets you an additional win. So here are the top 10 players in the NHL from that period. These are not necessarily per play, again, because we have some players here who are on the ice quite a bit. When we multiply by their number of events, we get some large values. Again, right, over a 2-year period, we're seeing the best players worth about 9 wins. For the season, nice that we see Connor McDavid there. Always worry if the best players that people think are the best players aren't necessarily there. Let's see, the bottom 10 players So far, no Canucks, though I think there's some players there that Canucks fans are probably familiar with. At least one who spent a considerable amount of time in Vancouver there. And then here are the Canucks players. I chose 5,000 events as the cutoff, and so I think there's 12 or 13 Canucks here with that. Interestingly enough, our Troy Stetcher and Bo Horvat end up next to each other there in terms of their number of wins contributed here. So Troy was doing some good things that possibly led to that +10 plus-minus rating. Obviously, Bo doing lots and lots of good things, even though his rating in terms of plus-minus not so great. Just mention a couple of things in terms of sort of some of these other effects. So that zone start, that is basically moving the start of your shift from the center of the ice or a shift on the fly to your offensive zone with an offensive zone face-off. That's like taking an average player off and putting Connor McDavid out there with you. That zone start is quite large. Home ice effect, nice to see that home ice effect there is positive. Again, small on a per event basis. If there's about 250 or 300 events per game, that works out to be about half a goal a game, which is pretty typical for ice hockey. And then the score effect is negative. So again, when teams are ahead, they are less likely to have good things happen. Some debate in the community about whether that's because they're less aggressive or because the behind team becomes more aggressive. Sorry, went backwards there. This is just a little bit on the literature there. Historically, a lot of this RAPM comes out of basketball. And so I've given you some of the references. More recent applications in hockey, Brian McDonald, Andrew Thomas, done some good work. Some new interesting work that's come out in soccer recently, as well as sort of North American football, and some interesting esports applications now coming out for this generally. So just want to wrap up sort of with the big ideas here. We're sort of taking a big data regression model approach, and we're looking to try and isolate sort of the average impact of a player on particular outcome, right? We've got to choose that outcome wisely. We want to worry about additional factors, appropriate units, and as always with statisticians, we worry a little bit about estimation methods. Couple of final thoughts, right? Multicollinearity is still a big problem. We try to deal with it, but that is a real challenge. We're assuming the same impact of each player. So regardless of whether the player takes the shot or whether they were not necessarily involved, right? On a breakaway, the shot could have occurred and they were 150 feet away. We're assuming the same impact of each player. That allows us to tease out an average effect long-term, but we've got to have a lot of data for that. We're averaging effects of players, so we're assuming the same effect of a player at the beginning of 2017 as we assumed at the end of spring of 2019. I mentioned some use of some GLM sort of logistic models depending upon your response. Non-even strength presents challenges. If you're going to go a Bayesian route, some prior selection choices are interesting, and long-term we're going to have tracking data, which should help us a lot, but is also going to mean more and more and more data. I've had some great collaborators in terms of the stuff that I've done, and a couple of them working on professional sports teams now, so acknowledge the help and the work that they've done there. And that's all I've got for the prepared slides, but I'll happily answer more questions.
Awesome. Thank you very much for the great talk. Okay, so excuse me, I'm going to yeah, if you have a question, please just put in the chat to me, and I'll go through the names. So just please be ready to interact with Dr. Schuckers. So the first question is from Dr. Tom Logan. I wonder about standard errors. Ridge regression doesn't have these built in, but can be teased out using more advanced methods.
So it's a great question. Almost no one has been all of that worried about them. You know, we can sort of get I guess it's the maximal posterior estimate of those from Ridge, or doing a fully Bayesian paradigm there. But there has not been much focus and work done on that and trying to sort of tease those out.
And naturally, it would be interesting to know, you know, are these top players really that much better than the bottom players?
Yeah, I think, you know, thinking about something like this, I think we have a good sense that those very top players are much better than the very bottom.
Yeah.
I think where it gets murky is, you know, how far away from zero are we willing to go to say somebody is really making a positive overall impact. But yeah, it's a great question.
Okay, just waiting for questions in the chat form. I'll ask one. So can you just comment on the quality of the data, like the NHL play-by-play data, and like, you know, how much you have to clean that up? And I mean, it seems, you know, 560,000 events is a lot. How long does it take to go through these data and process them? And what data quality control have you done other than just to sort of validate the model predictions in sort of the way you did towards the end of your talk?
So about 5 or 6 years ago, did a whole bunch of work on looking at how similar things were from rink to rink. But that is a relative comparison of events and not necessarily an absolute to ground truth. The absolute to ground truth may eventually come with tracking data, but I don't think we've done much with the quality of what the NHL is giving us. That said, I think the quality is good, plus or minus maybe 2 or 3%. 4 or 5 years ago, I would have said plus or minus 5 or 6%. But I think the NHL has worked on improving, in particular, their shot location estimate. So, you know, one thing that's not present here, right, is you're told that it was a wrist shot in the offensive zone from 35 feet. If you dig into the raw file, you can actually get X and Y coordinates for that. Now, the recording process is that 6 people sit at the very top of the arena and record that location. So there is a bunch of measurement error that is no doubt happening with that. It does seem that that measurement error has reduced over time.
And yeah, okay, so that's interesting.
Yeah, and
like, have you ever just like watched the, like, you know, you go through, take some game records and then just watch the game, you know, the video of the game, and try to, you know, align or verify the play-by-play?
Yes, at a high level, not at a particularly granular level. And certainly there are plenty of events that are missed. You know, I think lots of folks in the NHL would tell you that there are hits that are missed. There are sometimes shots that are missed as well.
Great, thanks. Dr. Tim Swartz is next.
Thanks, Michael. That was a great talk. I really like this stuff that's so practical and incorporates good hockey sense. I'm wondering if you can comment on the player tracking data. We've been like teased by this for years. Do you know when it's coming and who's going to get it? Anything you can tell me about that?
It's a great question, Tim. We've been teased for going on about 4 or 5 years, I think, about this. I think, so Andrew Thomas, who is referenced in there and is one of the sort of, I guess, luminaries in sort of hockey analysis, has joined SMT, which is going to be the company that is providing that data to the NHL. And I know Andrew pretty well, and I think there's some confidence that for the next regular season, that is going to happen. Whether it happens for this particular set of playoffs, I do not know. I suspect that there may be some testing that goes on as part of that. That said, what's going to be public? My guess is we're never going to have a full public data set. We may get some small pieces, but I don't think we'll ever get full access to the full play-by-play.
Thanks.
Great, thanks. And Danny Chu commented that the latest that he's read is that the later round of playoffs should have it this year, but who knows if that's true. So there's your insider answer.
Yeah. If anyone should know, Danny should know. So
yeah. So the players are, Danny, could you just comment what are the systems that are used for player tracking? Is it video based or some sort of RFID tag, or what is it?
Yeah, they've gone with RFID tags. I think the biggest constraint there, hearing from Andrew, is that they wanted it to be live, integrated into broadcast. And so that's kind of been the biggest challenge. And I think the cameras that the NBA uses take a while post-match to process. I don't know, anyone can correct me if I'm wrong, but that's how I understand it, is that they've gone with the RFID chips. And that the RFID chips that are used in the NFL are better at collisions as well. So when you go into the boards quite tightly, they do a better job than the cameras do. So that's how I understand it. The last thing I'll say is publicly, the data, I doubt it gets out in full forms. We'll see like what the public is able to parse out, but I've seen the price tag on some of the advanced stuff they're trying to sell, and it's very big. And so if you were going to get it out into the public when they're asking that much privately, I would be very skeptical it's going to get out in its full forms, but hopefully we'll see initiatives that get it out in small samples at least.
Right on, thank you. Hey, other questions for Dr. Schuckers? We're wide open here. Okay, so I think at this point, looks like we're out of the questions. And so if anyone wants to stick around, Dr. Schuckers, do you have a few minutes in case there's a
Sure.
couple of people to discuss? Well, so there's one question from Matt. Do you want to ask it now?
Yeah, sure. I'll just unmute. Thank you, Michael, Dr. Schuckers, for your presentation. It's been nice to hear about hockey again. It's been so long. In terms of my question, I guess I have two quick ones. Hopefully they'll be easy to go through. I noticed that in your Thor rankings, the most of the top players happen to be on the power play 1 unit for their team. And Colton Parayko is one that stuck out to me especially because typically he didn't really have a strong season, at least as far as counting stats go. So I was just kind of interested, is there a reason or a way to control for opportunity here as much as there is for outcome?
There is not. I guess the way that would be controlled for here is basically just that total number of events, right? And if the vast majority of the events when he is out there, then that will be higher. Now, this is purely even strength, so we haven't covered any sort of special teams with this particular method. That's a whole bit more complicated model, and so I've just sort of, in interest of time, avoided it. One thing here that would be of interest and possibly of utility is weighting the length of those events. So each event in this case is counted as a single event, not by the clock time sort of between events, and we have talked about doing that. We've never actually implemented it.
Okay, and that's a nice answer. I guess I had missed the purely even strength part of this, so thank you for clarifying that. And
Sure.
in a slightly different question that I had earlier as well, we're using probabilities in our response. Are all periods homogeneous in terms of how their probabilities are estimated? The second period has the long changes, so I wonder if there's different probabilities of scoring as events wear on.
There is. The first and third are different from the second. The second is actually a little bit higher.
Mm-hmm.
In what we have done here, we have not adjusted for that. We're getting down in terms of shots, because we're using actual location and doing a little bit of shot mapping. I guess I worry about sort of parsing even further. Though with 2 seasons, maybe that's not a big deal, but we haven't done it. And that's a good thought. It's probably something that should happen because the second does behave slightly differently than the first and third.
So, thank you.
Yeah.
Great, thanks, Matt. I'll just wait for a few seconds for any last questions. Okay, so if that's all we have, I'm just going to end the recording now, and I will thank Dr. Schuckers once again. And for those of you who want to stick around for a bit, I'll be online for another 10 minutes or so, and we can have a little bit of a discussion. So thanks again.
Yeah, thanks for having me.